Thank you so much. So what I will talk about is the energy transition, and not only energy transition as such, but the difficult part in decarbonizing the energy systems towards net zero by 2050, because that is what we have committed to, both as a company, but also as kind of countries, in particular in Europe. And of course, this will imply a lot of electrification, a lot of renewable electricity generation by wind and solar. And we as Equinor are very much committed to that. So we are investing in what will be the world's largest offshore wind park, just to mention one thing. And we are involved in lots of wind parks in both in Europe and also in the US. But that's not what I will talk about. I will talk about the molecules, not the electrons, and how we can decarbonize the molecules. Because the fact is that in the energy system today, actually 3/4 of the energy system consists of molecules. Only a quarter is electrons. And if we're going to reach net zero, we need to also decarbonize the molecules. Some of them can be replaced by electrons, by electrification, and the battery electric vehicle is just one good example of that. But there are lots of sectors where this is not possible, where we simply need to decarbonize based on the molecules themselves. And what you see in front of you now is the portfolio of what we call low carbon projects that we are embarking on in Equinor. And these are all targeting what we call the hard to decarbonize sectors. And low carbon solutions is kind of a combination of CCS, so carbon capture and storage, and hydrogen, either blue or green. Blue hydrogen is hydrogen produced from natural gas, which unfortunately emits a lot of CO2. This CO2 can be captured and it can be stored, and that's what we call blue hydrogen. And green hydrogen is based on renewable electricity from wind or solar or hydroelectric, and then run through electrolysis to also produce hydrogen. So hydrogen will be the same, but the origin and the value chain are very different. But in both cases, blue and green, we're talking about hydrogen produced without any CO2 emissions. And we are pursuing both, and this is the portfolio we are working on, as you see in front of you. So to the left, you see one project that we are involved in the UK, in Teesside. And this is what will become a modern gas-fired power plant. The plan is to capture the CO2 and then to store the CO2 permanently. That's what we call post-combustion capture, capturing CO2 from the exhaust, basically. And then we have a portfolio of CCS acreage, Northern Lights. I will talk more about that shortly. It's located in Norway, but it is a concept for the entire Europe. We also have a license in the UK together with BP and National Grid Ventures called the Endurance. And this is based on a pipeline solution collecting CO2 from the two largest industrial clusters in UK. And then we are mapping the North Sea for additional storage potential, because we see that the potential for storing CO2 is very large now that we all have committed to a carbon neutral energy system in 2050. Then there will be a lot of CO2 that we need to deal with, which we also need to capture. Moving on to the blue hydrogen portfolio that we got, we have divided this into 3 clusters. One cluster in Norway, in the short term, focusing on the maritime sector, and I will also talk more about that shortly. But we're also looking into blue ammonia. And ammonia is hydrogen and nitrogen. It can be used as an energy carrier in addition to a chemical component as it is today. Ammonia is the main kind of feedstock for fertilizer production, but it can also be used within the energy system without releasing any CO2 emissions. So we are involved in one ammonia project in Norway as well. In UK, Equinor, together with Northern Gas Network and Cadent, 3 years ago, we designed a solution for how UK can replace natural gas with hydrogen in the domestic heating market. I believe that really set the standard of how we could develop large-scale hydrogen solutions. But it is within a sector which is really hard to decarbonize, and probably it's going to be the last one to go through that development. So in the shorter term, we are now focusing on the Humber region, which is the largest industrial cluster in UK, and I will also touch upon that shortly. And in Northwest Europe, which in this sense is defined as Germany and the Netherlands, we are involved in flexible power generation without any CO2 emissions based on natural gas, and we are also involved in steel production together with ThyssenKrupp. And finally, we also have a major green hydrogen project in our portfolio, the North H2, which is located in the Netherlands. This is a project together with Shell and Gasunie and RWE. It's still in the planning phase, and the plan is to kind of dedicate a wind farm of really large scale. It's going to be the world's largest, and dedicate the energy production or the electricity production to electrolyzer facility, which then will produce enormous amounts of green hydrogen supplying the European energy market. So if I then move into a little bit more detail on some of these projects, I will start with Northern Lights, which I understand you have probably heard about before. The important part of Northern Lights is that this is a CCS value chain, which we kind of establish. Previously, all CCS projects have been what we call within the fence, basically that we have capture and storage in the same location. What we do with Northern Lights, which is so innovative, is that we introduce these ships, which will enable us to collect CO2 from any harbor in Europe, and then we will ship the CO2 to this facility you see on the screen, where it will be temporarily stored, and then it will be pumped into an offshore storage location 3,000 meters below the seabed for permanent storage. This is unique because what we will do now is that we will offer a solution for all those industrial sites who have the ambition to deal with their CO2 emissions but don't know where to get rid of it. Basically, what you see here is the market potential, all the potential sites which are able to capture CO2 and bring it to a port, basically a port where we can come and collect it with our Northern Lights concept. So this is a market which doesn't exist today, and as you can see, the kind of outlook for this to become material is definitely present. This is the kind of theoretical maximum market. If we look at those who have approached us, it kind of it overshoots the capacity that we have for storage almost with a factor of 10. So very promising start for how to develop this CCS market. Moving on to the hydrogen projects, I would like to spend a little bit of time on what we're doing in Humber in UK. And UK is a very kind of a favorable location to develop these low carbon solutions for the hard to decarbonize sectors. There are very good kind of systems for basically funding these initiatives in this phase we have up until the final investment decision. Remember that these are solutions that are difficult, they are expensive, but they solve a problem within a sector that doesn't have any kind of alternative solutions. So it's really important for society that we succeed on this journey. And UK has a favorable system, as I said, for managing this. So the project we are working on in Humber, we have actually submitted a plan for how to, an application for a demonstration plant of a very large scale hydrogen facility where we will produce hydrogen from natural gas. We will capture the CO2, store the CO2 in this endurance concept I talked about. And then we will supply a local power plant, which exists today, Today they burn natural gas. We will enable it to burn a mix of 30% hydrogen and 70% natural gas as the first step. During this step, we will be able to reduce the CO2 emissions by close to 1 million tons. And then we have further plans for this region. As a phase 2 and 3, we can step up the production of hydrogen, enabling 100% fired power plants with hydrogen, basically giving the option of producing flexible power when the wind doesn't blow without any CO2 emissions. That is a solution that doesn't exist today. We also look at traditional gas-fired power plants where we will be able to capture the CO2 and then store the CO2 permanently. We're looking at steel production, and we're also looking at capturing organic CO2 from a local power plant operated by Drax. This used to be fueled with coal. Now they are importing biomass from Canada and the US. And the CO2, which is the result from burning biomass, is what we call organic CO2. It doesn't count in the emissions, but it can still be captured. And we will look into capturing this organic CO2. And then we have two choices. We can store it, and it will then count as negative emissions, or we can mix it with clean hydrogen and produce artificial fuels. So there's a lot of exciting industrial developments going on in this region. And we aim at fully decarbonizing the Humber region by 2040, which is a huge step, as it today is the largest single point of emission of CO2 in the UK. Moving on to Germany, we are working together with ThyssenKrupp, which operates probably Europe's largest steel facility. And today they use coal as the reduction agent to basically extract the oxygen from the iron ore. And what we're looking at together with them is to see if we can replace coal with hydrogen. And if we do so, we will get water as the byproduct instead of CO2. This is important also because of the size. And if you look at all the steel manufacturing facilities in Germany, if they were to use green hydrogen, so hydrogen from renewable electricity, it would actually consume the entire production of renewable electricity in Germany. So this is a good example of blue hydrogen from natural gas with CO2 capture and storage, just as clean, to demonstrate that this is an area where we need those solutions because of the scale, because this is kind of a sector that requires really large-scale solutions, and we can deliver that based on natural gas and CCS. So finally, I will end my presentation with a small project. This is a green hydrogen project and actually upgraded to liquid hydrogen. It's in Norway, and it's based on extracting electricity from the grid. And the grid in Norway is very clean, almost entirely produced from hydroelectric power. And the role of Equinor in this project is actually twofold. So we will, together with our partners BKK and Air Liquide, produce the liquid hydrogen. But as Equinor, we will also purchase the services and basically build the market for the operator of these vessels that you see in the background. Because the plan here is that the liquid hydrogen will be used on board these ships, basically as a battery. It will run through fuel cells, generate electricity, and electricity will power these ships, which will be fully electric and emission-free. These ships, as I said, are cargo vessels. We plan to operate them between the bases that Equinor operate today. And today we have 40 trucks traveling on road between these bases, and we plan to shift this cargo from road to sea, and by doing so, stimulate the market for this seaborne freight transport. So here, it's a good example that we are using our purchasing power in a smart way to generate the market that we will then deliver the hydrogen into. So I think I will end my presentation there, and if there are any questions, I'm happy to take those.
Many thanks, Steinar. That was very, very informative. I'm very interested in hydrogen generally. I think that's one of the the more talked about topics on energy transition. And what was interesting you mentioned, which I wasn't overly aware, is you've got, is it green hydrogen that emits, no, not sorry, the blue hydrogen that emits the most emissions, but then you've got a problem with green hydrogen that is not scalable enough. So clearly there's probably a hybrid going on there, which is interesting. I do want to ask you one question though, one thing, because you mentioned electrification, you talk about hydrogen, you talk about wind, you talk about solar, and you've obviously done some incredible things with Equinor on these areas. With this energy transition path everyone's going now towards, where do you see it going in terms of, like, will there be a dominant renewable source that people are going to take on board? Because obviously we're still talking about all of them. Is there not going to be one that's going to probably take over, or are they going to be used in tandem? I'd
No,
like to probably know your opinion on it.
yeah. No, you need all of them basically, and just to go back to the green versus the blue hydrogen. So you are right about the scale. The blue has the bigger scale, but we can make it just as clean, and the plan is to make it just as clean as green. So there's no difference there, but it's the origin of the energy source, which is fossil, which is kind of unfortunate, if you like. It's not that kind of sustainable in the long term solution. But it doesn't create any emissions because we will manage the CO2 and bring the CO2 back to the reservoir, basically, or to another reservoir for permanent storage. So it has the same kind of CO2 emitting characteristics, but it has kind of a different origin, basically. But we are very, very clear that we need both. And there is not a silver bullet that will solve this. You see that in several sectors, and you also have differences between geographical locations. So for instance, if you look at the solar, if you look at Florida and California, they have good conditions and they can use batteries which they charge during the day and they deplete during the night. We cannot do that in Norway or in the UK simply because we don't have the sun conditions. So we need other solutions. And that will be the case for the rest of the world also. So in different places, you will find different solutions. So that's why it's so important that we develop the full spectrum of solutions.
Yeah.
And what I presented to you now is what we do within the difficult end. Of course, we also do the simple stuff with the wind and solar, but the difficult part is where you need large amounts of energy storage. So basically to deliver electricity when the wind blows, that's simple. That's just a wind turbine. But to deliver electricity when the wind doesn't blow and when the sun doesn't shine, that's the challenge. And it's really a challenge if you have an unpredictable pattern when it comes to solar and wind generation. So those are the solutions I presented that we are working on, which the world will need if we're going to go towards net zero. Otherwise, we would just be able to reduce the CO2 emissions by a fraction, and that's not good enough.
No. One other thing I wanted to ask you, because those initiatives that you're running together with some other operators, I mean, the Northern Lights initiative is excellent. It's something very, very different. Do you foresee past this more collaboration with other operators? Because obviously we know, and we hear it a lot with even technology conferences, that energy transition is becoming more of a conversation point with technology. So I would assume that you would have more collaboration with the Shells, the Chevrons, the Exxons going forward. But is that sort of the path that you're going towards as well, is getting more collaboration with other operators?
I think I would like to put it as we are going to collaborate vertically instead of horizontally. Because if you look at the oil and gas sector, we traditionally have had partnerships. If you look at a gas field, an oil field, or a terminal, or whatever, typically there are partnerships where we, together with Shell and Exxon and BP, own and operate these things. But what we see with these solutions is that we collaborate together with our suppliers, together with our customers, to kind of get the whole value chain up and running. Because we are dependent on them and they are dependent on us to get these new technologies operational. So I think there's a much more, it's much more common, or would be much more natural to see vertical collaboration in the value chain compared to what we have seen in the energy sector traditionally. Because today in the oil and gas sector, we just sell our product at the marketplace. But when it comes to these hydrogen solutions that I've talked about, we need to create that market as well as producing the hydrogen. So it's much more complex and difficult. So that's why you need these vertical partnerships.